Right, so we begin with just the information. We have a triangle with angles A, B, and C. All right, so one possible way that we can approach this is, let's go ahead and create a circle around this triangle. And so this is called an inscribed triangle. It means we have a circle that passes through each of its vertices. Okay, and so in looking at this, we'll call this triangle ABC. All right, when we look at this particular measure, if we know that angle A has an angle measure of A, what is this intercepted arc going to have to be? So angle A is an inscribed angle, so this intercepted arc is going to be what? 2 times A, right? So the measure of arc BC is going to equal 2A, and we know that because the intercepted arc is equal to twice the inscribed angle. Okay, so this was one of the relationships that we talked about in the last chapter, in chapter 4. And so we know that that's the case for arc BC. What about arc CA? The measure of arc CA is going to equal what? So its inscribed angle is B. So this intercepted arc is going to be 2B. And then finally, again, it's the same justification, so we can leave it as the same step. And then finally, the arc measure AB is going to equal what? So here's its inscribed angle is C, so it's going to have a measure of 2C. And so those are the measures for each of these individual arcs on this circle. Now, what do we know the full rotation around a circle is going to be? So if we take BC plus CA plus AB, all of those arc measures, it's going to add up to 360. And so you can justify that with either definition of circle or just that the full rotation of a circle is 360 degrees. Okay. Again, anytime you're going through a proof, if you explain your concept, you can write it as a sentence, you can write it as abbreviations or accepted abbreviations. Okay. And so now what we can do is we can take each of these individual parts now, we can plug them in. So BC can be substituted in for 2A, 2B can substitute in for CA, and 2C can substitute in for AB. So this is an example of substitution only. We simply plug in equivalent values for their equivalents. And that's going to lead us to this final statement. And what can we now do to every term in this entire equation? In order to get A plus B plus C, we have to divide each term by 2. So if we divide each term by 2, we get our final statement. And that's division property. And we come up with our final statement. So now we have this theorem, which says that the sum of the angles in a triangle add up to 180 degrees. And so we can now use this in any future proofs.